Here we have algebra 2 problem. There is an equation given over here. That is x to the fourth power negative 4x cube positive 4x square positive 36x negative 1 and 17 equals to 0. If 2 positive 3a is one root of the above equation, find the other roots. Okay, actually it's a equation of degree 4. That is the largest exponent of the variable x is 4. Since the degree of the equation is 4, we'll have 4 roots for this equation. So in those 4 roots, one of the roots is given in the question itself, that is 2 positive 3a. And we have to find the other roots, I mean the remaining 3 roots we have to find. Okay, when I look at the given root 2 positive 3i, it's a complex root. Usually for an equation, the complex root will always occur in conjugate pairs. That is, if 2 positive 3i is one root of this equation, then 2 negative 3i must be the one of the roots of for the same equation. Let me write over here, must be one of the roots. Let me write it. Okay, now, so we have, I said that since the degree of the equation is 4, we have 4 roots for the equation. We got 2 roots now. One root is given in the question itself. So using the concept, that is a complex root will occur in conjugate pairs, I got one more root, that is 2 negative 3i. So now I have to find 2 more roots. So for that, what I'm going to do is, I'm going to find a quadratic equation which has the roots 2 positive 3i and 2 negative 3i. Here you may have a question, why should we find a quadratic equation which has roots 2 positive 3i and 2 negative 3i? So I'll tell you the reason little later. So whenever I know the 2 roots, there is a formula to get a quadratic equation. I'll write the formula over here, that is x square negative sum of the roots. Let me write the stuff over here. Sum of the roots times x positive product of the roots. Let me write it. Product of the roots equals to 0. Okay, here x square negative sum of the roots means I have to add the 2 roots, 2 positive 3i and 2 negative 3i. Let me add them, 2 positive 3i positive 2 negative 3i times x. And now what I have to do is product of the roots means I have to multiply the 2 roots. 2 positive 3i times 2 negative 3i equals to 0. So here positive 3i negative 3i will become 0. Then we get x square negative 2 positive 2 will become 4. And here we have x and 4x. Positive. So now we have to multiply these two binomials, 2 positive 3i and 2 negative 3i. So we can use that algebraic identity, that is a positive b times a negative b. So equals to a square negative b square. So whenever we have difference of two squares, that is a square negative b square, it can be written in the factor form, that is a positive b times a negative b. And whenever we have a product of two binomials like this, a positive b and a negative b, so it can be written as a difference of two squares, that is a square negative b square. So comparing this and this, we get 2 at the place of a and we get 3 at the place of b. So for this product, what we can write is, we can write this a square negative b square by replacing a by 2 and b by 3i. Okay, now let me do it over here. So then we get 2 square negative 3i the whole square equals to 0. Then I'm getting x square negative 4x positive 2 square is 4 negative. So here 3 and I are multiplied and we have the common exponent. So whenever two quantities are multiplied and we have the common exponent, the exponent can be taken separately for each quantity. In that case, I'm getting 3 square times I square equals to 0. X square negative 4x positive 4. So 3 square is 9. So since I is an imaginary number, we know that I square equals to negative 1. So the value of 3 square is 9 and the value of I square is negative 1 equals to 0. Then I'm getting x square negative 4x positive 4. Negative times it will become positive, 9 equals to 0. So then we get x square negative 4x. So when I combine positive 4 and positive 9, I'm getting positive 13 equals to 0. Okay, so here I got a quadratic equation using the 2 roots, 2 positive 3i and 2 negative 3i. Since these two numbers, 2 positive 3i and 2 negative 3i, are the roots of the given equation, the quadratic expression we have over here must be one of the factors of the polynomial we have on the left side of the given equation. So using this x square negative 4x positive 13 as one of the factors, so what I can do is I can try to factor the polynomial we have on the left side of the equation. So once I factor this polynomial, I'll be able to find the remaining 2 roots. So how do we have to get the other factor? So for that, what we can do is we can use long division. Okay, let me write the long division over here. So in long division, we have to take this polynomial as a dividend, that is x to the 4th power negative 4x cube positive 4x square positive 36x negative 1 and 17. And we have to use this quadratic expression as divisor over here, x square negative 4x positive 13. Okay, my first step, what I have to do is I have to divide the first term of the dividend x to the fourth power by the first term of the divisor x square. So when I divide this x to the fourth power by this x square, I'm just getting x square. So now I have to multiply this complete divisor by this x square. When I multiply this x square by x square, I'm getting x to the fourth power. When I multiply this negative 4x and this x square, I'm getting negative 4x cube. And when I multiply this x square and positive 13, I'm getting positive 13x square. Okay, now what I have to do is I have to subtract the expression we have over here from the expression we have at the top. Since we do subtraction, so we have to multiply the expression at the bottom over here by negative sign. Already it's positive x to the fourth power. When I multiply by negative sign, it will become negative x to the fourth power. And when I multiply this one by negative sign, it will become positive 4x cube and it will become negative 13x square. So positive x to the fourth power, negative x to the fourth power will cancel out, and negative 4x cube, positive 4x cube will cancel out. And when I simplify, I mean, when I combine positive 4x square, negative 13x square, I'm getting negative 9x square, and we can bring these two terms down. When I do so, I'm getting positive 36x, negative 117. Okay, the next step, what I have to do is I have to divide the first term of the expression over here by the first term of the divisor x square. So that is when I divide 9x square by x square, so I'm getting negative 9 because this x square will cancel out. So and also we should not continue this process anymore because we get the same exponent for the variable x in numerator and denominator. So when we do long division, when we divide the first term of the expression over here by the first term of the divisor, so if we get the same exponent for the variable in both numerator and denominator, we should not continue this process anymore. So when I divide this one negative 9x square by this x square, I'm just getting negative 9. So I can write this negative 9 over here. Now I have to multiply this divisor by this negative 9. When I multiply this x square by this negative 9, I'm getting negative 9x square. When I multiply this negative 4x by negative 9, I'm getting positive 36x. When I multiply this positive 13 and negative 9, I'm getting negative 117. Okay, now again, I have to subtract the expression at the bottom over here from the expression at the top over here. Since I'm doing subtraction, always I have to multiply the expression at the bottom by negative sign. So then this negative 9x square will become positive when I multiply by negative sign. This positive 36x will become negative 36x, and this positive negative 117 will become positive 117. So positive 9x square, negative negative 9x square, positive 9x square will cancel out. Positive 36x, negative 36x will cancel out. Negative 117, positive 117 will cancel. I'm getting 0. So definitely I'll be getting 0 here. So because I got this quadratic equation using the two roots of the given equation, 2 positive 3i and 2 negative 3i. Since I got this quadratic equation using the two roots of the given equation, so this already we know that this quadratic expression is one of the factors of this polynomial on the left side over here. Since x square into 4x positive 13 is one of the factors of this polynomial, so when I divide this polynomial by this quadratic expression, I'm getting remainder 0. Okay, then what is the other factor of this polynomial? That is the quotient that we get in long division, that is x square negative 9. So now we got two factors for the polynomial on the left side of the given equation. So one factor is the quadratic expression we have over here, x square negative 4x positive 13, and the other factor is x square negative 9. That's the quotient of the long division over here. Okay, now let me continue on the next page. Here we have the given equation, and already we got the two factors of the polynomial we have over here on the left side. So the first factor is x square negative 4x positive 13, and the second factor is the quotient of the long division, that is x square negative 9 equals to 0. So here the product of two terms, two quantities equals to 0. So whenever the product of two quantities equals to 0, either the first one has to be 0 or the second has to be 0, or both of them can be 0. So x square negative 4x positive 13 equals to 0, or x square negative 9 equals to 0. So here we get two quadratic equation. So usually we have two roots for a quadratic equation. So we get two roots for this quadratic equation, two roots for this quadratic equation. In all, we get four roots for the given equation. But we don't have to solve this quadratic equation because we got this quadratic equation using the two roots, 2 positive 3i and 2 negative 3i. So even if I solve this quadratic equation, I'll be getting the same roots, 2 positive 3i and 2 negative 3i. So we don't have to do that one. Let's solve this quadratic equation. So for that, what I'm going to do is I'm going to add 9 to both sides. When I add 9 to both sides, negative 9, positive 9 will cancel. I'm getting x square equals to 9. Now to get up the square over here, I'm taking square root on both sides. So in an equation, whenever I take square root on both sides, for one of the square roots, I have to consider positive and negative sign. So usually we take positive and negative sign for the square root which contains a number inside it. So here in the square root on the right side, we have number 9 inside. So we can take positive and negative sign for this square root. And here on the left side, the square root and square root cancel out. I'm getting x equals to positive or negative. Square root of 9 is 3. So here we get two roots. The remaining two roots are positive 3 and negative 3. So like in the given, in the given information, already we have one of the roots for the given equation of degree 4, that is 2 positive 3i. And since it's a complex root, I said that complex root will always occur in conjugate pairs. So from this, I decide 2 negative 3i must be the other root. One of the roots of the given equation. So we can consider that one to 2 negative 3i. So apart from the given root 2 positive 3i, so the other roots of the given equation are 3 negative 3, 2 negative 3i.